So in this lesson, we're going to take a look at focusing on slant asymptotes. So this is the same vocab sheet from yesterday if you want to pull it up and make some notes. If there is no horizontal asymptote, meaning the leading coefficient of the numerator is greater than the leading coefficient of the denominator, sorry, not coefficient, degree. The degree of the numerator is greater than the degree of the denominator. There's no horizontal asymptote. Then what you need to do is check to see if there could be a slant asymptote. So the slant asymptote occurs if the leading degree of n is 1 more than the degree of the denominator. So for example, if you have x cubed minus 8 over x squared minus 1, the degree of the numerator is 1 bigger than the degree of the denominator, so there will be a slant asymptote. We'll use long division and ignore the remainder. The quotient will be in the form of a line. Your slant asymptote will always be a line after you finish your division. So let's take a look at an example. The first example, we are just going to figure out what the slant asymptote is and graph just the slant asymptote. We're not actually graphing the function, we're just graphing the asymptote. So notice the degree of the numerator is indeed 1 bigger than the degree of the denominator. So we're going to set up our long division. Notice how we're missing the x term, so I put the 0x in there. X, of course, times x gives us x squared. Subtracting, bringing down the 0x. I can go ahead and skip the plus 0, and we've got the remainder of 5. Well, we ignore the remainder. So our slant asymptote is the equation y equals x, and that is coming from the quotient or the answer of your division, not the denominator in this case, because they're the same. That could be a little confusing. So graphing our slant asymptote y equals x is fairly straightforward. We've got a y-intercept of 0 and a slope of 1. So remember, obviously this is the graph of the asymptote. This is not the graph of the function. In the next video, we're going to look at how to put the slant asymptote together with the function. But this one, we're just practicing finding the asymptote in the first place. Again, notice on this example, the degree of the numerator is 1 bigger than the degree of the denominator, so we're going to have a slant asymptote. So we set up our long division. I needed a couple of placeholders on this one. Dividing by x squared minus x. X squared times x gives us x cubed, multiplying. Again, when you do your long division, make sure you change the sign so that you can add your like terms instead of subtracting them. X squared goes into x once. Change the signs. And x squared does not go into x minus 1, so that's our remainder, which we ignore. So the slant asymptote is the equation y equals x plus 1 from the quotient. Graphing just the slant asymptote, we've got a y-intercept of 1 and a slope of 1 again. Sorry, trying to go by 2's to get this graphed a little bit faster. So this would be just the slant asymptote of the graph.